Hi everyone, I'm super excited to be here. And today's talk will be about how to build AI-powered apps without vector database. Because when we talk about building AI-powered apps, which means you are building a data pipeline, right? And first of all, let me introduce myself. My name is Bobur. You can call me Tiger, which is in English. It will be more convenient. And also, feel free to reach out to me on the social media channels, not because of my branding. I really want to get a feedback about what I'm going to show today, because we are at the early stage of building open source framework for large language model apps. And this is my video from yesterday. I did 10 kilometers of running through the Bilbao. It's a wonderful city. First takeaway from that presentation for you, if you go into the new city, just take a bicycle or run. It will be a streaming mode and fast mode, right? And here's a static mode, where I'm staying just after the walk. And it was great for me, like 10 kilometers, which means I went to one side of the river and came back from the different side. So the same works with our tool, what I'm going to present today. It's how it's easy to convert batch processing code to streaming mode, or vice versa. If you have a streaming code, you can convert it to some sort of static code. That's how demonstrated this small GIF. Assume that you have some CSV data comes in. In reality, it can be any structured data, unstructured data, right? And then you can test it in static mode and just change one line of code to make it streaming so that you can have a real-time data. That's how we call the pathway. There's a project called Pathway. When you do pathway run, it runs in streaming mode. So LLMs. I hope everybody knows, right? LLM, this large language model, because of this popularity of OpenAI GPT nowadays. Because it sets records in January, having a largest user base, right? Billions of people are, they are really started to chat and ask questions, because nowadays even going through the large amount of documents can be simplified using LLMs. It doesn't mean now it's not a hype anymore, right? Not a blockchain, not a Web3 technology. There's a lot of companies, they are building good stuff, bad stuff, strange things. What I built here, as you can see, I built my own app, using also my tool, or our tool. That finds some discounts in the market. Assume that you have Amazon products, online markets. I can search for some discounts just from the chat interface, and it can show me some discounts. You will see if you have enough time, the whole demo, but it can merge also multiple data sources. It works in real time. It's actually data coming from Amazon. Still, there are some limitations, right? No, ChatGPT, for example, as maybe you already know, you cannot see some events happening after 2021, and you cannot train your data on non-public private documents, right? And some other solutions comes in, like manual approaches, doing prompt engineering. You just use a chat interface, OpenAI, and give input to use as additional help to the GPT, right? For example, I tested out here, I just extracted the response from coming Amazon product API, and I put into the text input message. And I can get some response, you see? I can search for discounts, because now ChatGPT is context aware. But it's about hyping, again, it's not like a production ready, because there are some issues still, in addition to some language issues, because now AI can respond in English very well. But in Spanish or in other languages, it's still lacking. So, in addition to language, is cost and latency also issue, right? Cost, which means you can give more input data to GPT, it can perform better, but at higher cost. You need to pay more for OpenAI. And about latency also, assume that you can take Hugging Face or other LLM providers, you never know how much time it takes. When you ask a question and your response coming back, they don't have any SLA. There is no promise. And also another issue, offline evaluation, for example, I am a software engineer, I want to test my code, like how AI responds. But you cannot do that, because you never know what kind of response you will get. Each time you ask, each time different response coming. And nowadays companies are trying to partially solve these problems. How they are solving? Using, again, like 2 popular endpoints, API endpoints, and Hugging Face also has Azure, OpenAI. Now, if you assume OpenAI, just the APIs, we have 2 endpoints, right? Embeddings and chat completion. What does it mean? If you have a large input data, you just chunk them into small pieces and calculate vector embeddings from each piece, and then use this information as an input to chat completion when you are building prompt. It will be easier and faster, right? Have you ever tried? Has anyone tried to build AI app? No? If you haven't tried, look at this. It's common architecture nowadays. If you look at now Google out, it's a very promising approach nowadays building AI app. Assume that you have some data as an input, right? API, file, database, OLTP as your data source. And what you just build a pipeline to extract the data. And from the extracted data, you just divide again this input data, calculate vector embeddings, and index them and store them to vector databases. That's a special storage that can store vector for future easy retrieval, right? Because vector database is dedicated for good vector search operation. If you think about vector is data type, and vector search is query processing approach, right? And from the other point, if I'm building product, how it looks like. User search something, I have a backend application, maybe API, whatever, and we are also calculating from the user asked question embeddings again. So this embeddings API and matching 2 index together to give a more efficient response to our human, right, to our system. This is a very famous architecture. I hope everybody can find it easily. But here's the question again, like problems comes in with vector databases because it is independent distributed system. We cannot use our own storage, right? And it leads us again the same problem. The same problem is problem with synchronizing data, problem with what if happens something changed, let's say on PostgreSQL. We are calculating on the same time vector search operation, vector database. It can show different information. That's a sort of data inconsistency, right? Next issue with the famous vector database is metadata filtering. What if AI, if you want to get specific response when you're asking AI based on the role, user role. For example, I want to get my discounts based on my shoe size. Right? Because AI should know my shoe size at least, or at least should know if I am a seller or if I am a buyer, like this. Or if you're calculating salary for your employee, this AI guy need to know if this role, who is asking this question, your review question, is your manager or just the employee. If it's manager, it can see this information. This metadata filtering is issue. And we are building, like since August, a new framework called LLM app. It's the name also suggests, right? If you Google it also, it will come on the first place with the company pathway that does real-time document indexing. What does it mean for you? You don't have to use vector databases. Your data can stay wherever they are, and then you can just do indexing in real time. Without having this additional storage. That comes with cost, infrastructure, skills, licensing, a lot of issues, right? And my architecture for the app I showed previously, that's how it looks like. I have, let's assume, a front-end application, and it asks backend, please find me discounts. And here, most important stuff is happening on the right bottom side. I am doing real-time indexing as time data comes in. Let's say I have API called Rainforest that gives me Amazon data, and I am indexing in real time. That GIF also demonstrated, right? And then what we are doing also integrating with OpenAI and with multiple language models. You can choose your models, which models you want. So, and what does give us this vector indexing? Of course, data privacy. You are minimizing exposing of your data using your own data source, right? Like if you have a data on MySQL, you can still use them. And it's cost efficient. Like you don't have to use additional computer power, or cloud deployment also easy, which makes it cloud native. It's just a Python application. And if you need storage, you can still like use your own storage. And if it's scalable, of course, less components to manage. And here, if you combine LLM app, we say it's just a framework in Python to build an application, which another called pathway. It's just an application layer to build unified data pipelines. You will have a LLM-enabled data pipeline for real-time data, right? You're analyzing real-time data and adding the power of AI. So this is how this unified data pipeline looks like, right? You can just in one Python code manage everything. You don't have to have, additional skills in data engineering, data science. I'm also not data science guy, but I'm a developer. I know how to develop things, but I can just run my code in different modes, batch, streaming, LLM pipeline, and test it out. And what gives us this benefit, if you look at this popular, very emerging LLM app stack nowadays, a lot of tools, technologies. I think a lot of my colleagues also showed this very complex architectures. This is the LLM apps architecture if you want to build something. But here you need to use LangChain, you need to use some sort of caching mechanism, right? You need to have also some APIs, specific APIs if you want to expose the data. But with the solution, what I showed you, like LLM app, you don't need vector databases, you don't need LangChain, which is famous LLM framework, you don't need any caching, you don't need API builders. So this is a sort of technology we are working on, still in progress. We have one actually already using startup companies already applying this tool, because they want to have this real-time indexing happening without even additional storage, right? And if you look at the code-wise, I hope everybody understands Python code, right? It's good enough to see. As you can see, how many lines of code here? Like 1, 2, 3, 4, 5, around 8, maybe 9. Huh? These 9 lines of code is actually my application that I showed previously. If you have CSV data, you're just reading CSV data. If you have more data coming from JSON lines, S3 technology, S3 storage, right? You can just combine this data as well to make more complex applications. From the code side, also simple, because library gives us flexibility on that. And if you want to have some sort of customization, it's also open source. But if you have like enterprise level of application offers you also, instead of using OpenAI, for example, you can also train your data with your own fine-tuning. And also you can customize this memory indexing, how you want to customize. If you want to opt out some data privacy things, you can also write in Python code. And key features, as I said, a lot of built-in connectors. You can connect to Kafka, you can connect to Redpanda, you can connect to any other streaming data tools, right? And as I said, local machine learning models, we are building and supporting more our also private local machine, which is good for enterprise. And also, if you want to give a try yourself, it's easy to start with. You can just add the LLM app to your Python project dependency, and you are good to go. If you're working on the Python, I'm not a Python developer, honestly. Like I built this application also easily because it's easy to understand. I know Java guy, but it's easy. And this is the second QR code. You can, if you want, like you can scan it. But the second QR code brings you, because we are limited in time, 20 minutes, right? I am also giving additional speech at the end of this month, September 29, about how to build a unified data pipeline with Pathway. It gives more like insights, practically how you can leverage these two technologies together. And takeaways, for me, I'm not like against the vector databases, but we need to start with simple infrastructure, right? That increases the performance without even worrying about like what's happening with your data or managing like a lot of distributed systems. And you can also use, for example, like Pathway technology. It's not like in infrastructure level, like it's not like a streaming database or special dedicated database or like Apache Flink, right? just use your Python sort of data science tools together with other Python libraries. A little bit integration also good. And you can use also our LLM app open source project to build some AI applications. That's all from my side. Now, if you have any questions, feel free to ask to me. We are a bit, okay.
You're really good.
Yeah?
You're very good. Round of applause on that. Round of applause on that. Do you have any questions from the audience? I will pick on somebody from the audience because you used a very special word that will be mentioned in a later presentation.
Who asks question?
So we're gonna get one of these. Alvaro, he mentioned the word Postgres. I gotta know your opinion. So we have a person in the room that if you say the word Postgres 3 times anywhere in the world, he will appear. His name is Alvaro. Take it away.
I imagine that.
Postgres.
Oh, thank you very much. Yeah, so no, I don't disagree with you. I'm a Postgres fan, obviously. So
PG Vector.
Yeah, obviously, I'm PG and whatnot, right? But there's, believe it or not, and I'll talk later about Postgres anyway, but believe it or not, there's use cases for using both Postgres and not Postgres. What I find hard is to find use cases for all the database like MySQL. But no, kidding. There's use cases for everything too. But I find it refreshing, an approach without having to rely on a database itself. In general, I would say that you're gonna face some challenges that maybe you can give us some more ideas, like, I mean, if you're doing real-time processing, when the pipeline fails, the processing, the machine fails, the node dies, you're going to need to kind of reconstruct this information, whereas when you process the state on a database, then you're going to have it there. So there's going to be some challenges, and maybe you can comment on this, but I really like to see this approach as a refreshing approach, as a different alternative. There's different use cases, and all may apply for different use cases. But anyway, now that I have to pose the question, is about that. So what do you do for high availability? How do you deal with failure of the pipeline, the nodes involved, etc.?
Yeah, I think it's a very common question. Nowadays, everybody's asking. Even when we try to put our open source project on OpenAI cookbook repo on GitHub, very famous, and they asked why, how to scale it, and asking. Of course, first is it has different use cases than usual AI applications, right? It can be convenient like pipelines when you run once and forget about it. And you just input the data and you do just AI help response and save the data as an output. It's very convenient. You don't have any additional storage in this center. But the additional storage you need when you want to have a scaling approach, what we are offering now only a built-in caching mechanism. Now caching still exists, but for even enterprise level, we have a special support for dedicated database. Even, I mean, you can combine with vector database in the future if you need one. But I'm also experimenting with PostgreSQL, by the way, page vector stuff, yeah. Because, you know, now as companies, even you can read now in the articles, vector databases are cool, but nobody are going to invest anymore in the future because you can invest more in creating special data type in OLTP database. It gives more flexibility, like page vectors, maybe one day becomes a bit more community friendly, right? I hope that answers the question, or we can maybe take it off and maybe I can explain more scalability issues.
It does for me, but happy to take it also later and talk more Postgres.
Sure, thank you.